So we're going to start out by looking at section 1.1. We'll do a little bit with the graphing calculator towards the end, but you don't need it right now. So the first thing we're going to look at is a diagram that shows different types of numbers. Now I'm not going to go through and write out the definitions of all of them. I will explain them, but we're going to start in the middle of that graph and work our way out. Middle numbers, or the ones that are in the innermost rectangle, are the simplest kinds of numbers, and the further out you get, the more complicated the numbers get. Okay? And the uses of those numbers become less and less typical for someone that uses numbers every day. So, simplest kind of numbers that we can work with in math are counting numbers. Okay? Counting numbers start with 1, and they go up. They don't include negatives, they don't include fractions, they don't include decimals. So when you count, you go like 1, 2, 3, 4. Those are counting numbers. The whole reason that we need more than just counting numbers is when we start to introduce arithmetic. Okay, so how about Alexis? Can you give me a counting number?
Any number?
Yeah, any counting number.
3.
3. So I'm going to do arithmetic, and I'm going to do 3 minus 3. The problem with 3 minus 3 is the answer doesn't exist as a counting number. Okay, because counting numbers start at 1 and they go up. We know what 3 minus 3 is, but it's not in this box. So what do? They basically invent something more than counting numbers, and that's what they call whole numbers. So whole numbers include every number from 0 and up. They don't include negatives. They still don't include fractions or decimals. But whole numbers, even though you have the number 0, you can still run into problems. How about Quinn? Can you give me a counting number?
2.
2. And how about Caleb? Can you give me another counting number?
1.
1. So the problem with that is 1 minus 2 is not a whole number. Right? If all you understood was whole numbers, you'd have to say, well, that's impossible. And if I showed that to somebody in like first grade, they'd probably say, yeah, you can't have the bigger number come after, in a subtraction problem. It doesn't work. Well, it does work. They just don't know how it works. We know how it works. We get negative numbers. And that's where integers come in. So integers include all the positives, 0, all the negatives, but they still don't include fractions or decimals. If all you did was add, subtract, and multiply, integers would be fine. If you take 2 integers and add them together, the answer that you always get is an integer. It's impossible to not get an integer. If you subtract 2 integers, you will always get an integer. If you multiply, you can always get an integer. But what operation could we run into a problem with? Yep. Division. You could give me an integer, like 5. You could give me another integer, 2. Divide them. And all of a sudden, when you divide an integer by an integer, you don't get an integer. You get something that's outside of the integer box. And we call that a rational number. So rational numbers are basically numbers you can write as fractions. As far as everyday kind of uses people have for numbers, rational is probably as complicated as people need to do. If you're maybe cooking something, you might not need 2 cups of flour or 3 cups. You need something in between, 2 1/2, 2 1/3. Right? That's a rational number. When you buy something, it might not come out to exactly $10 or exactly $11. It might be $10.32. 32 hundredths of the next dollar. It's a fractional amount. Right? So those are all rational numbers. So, rational numbers are numbers you can write as a fraction. Irrational numbers are numbers you cannot write as a fraction. Now I'm starting to get into numbers that are a little more abstract. Okay, numbers a little more, less common in everyday life. Can anybody think of a number that you can't write as a fraction? Yeah? Pi. So pi is an example of a number that you can't write as a fraction. If you type it in on a calculator. Let's just click here. And you press the pi button, you're going to see a bunch of digits. Do I have a pi button? Yeah. So it's 3.14159, and it just keeps going. Well, that's not the exact answer for pi, right? It just keeps going forever. It never repeats. There's no pattern to it. And honestly, if you were doing something, like let's say even you were like machining something, pi has to do a lot with circles, circumference. Well, if you were machining something, you can certainly machine something like on a CNC machine to the nearest thousands. Maybe you can even do 10 thousandths. But would you really need this many decimals? Are you going to be machining something to the nearest 100 billionth of an inch? I don't think you can machine something that precisely. Right? That's extremely precise. So that's why for everyday purposes, numbers that can't be written as fractions are usually rounded off, and that's how we use them. Pi is one of the best examples. So a lot of times we just use 3.14, and we just don't use the rest. Other numbers you can't write as fractions. Anyone know another type of number? Yeah?
Is that anything with like repeating, like 3.33 and repeating?
So if something repeats forever, then you can write it as a fraction. So you could do something like this, 2 1/3. So if a number does repeat forever and has a pattern, then it would be considered rational. But there's another type of number I'm thinking of that you can do this operation in math, and the answer a lot of times doesn't come out to a nice number. And by nice number, I mean something that's not a fraction. Think of something else you can do in math. It happens a lot when you do like Pythagorean theorem. Usually it's one of the last steps. Yeah? Square roots. Yeah. So square root of 4 or square root of 9, that's different. You know, those you get nice answers for. But I'm talking about a number that you take a square root of and the answer doesn't come out. Square root of 3 is an irrational number. Right? You take 3, take the square root, it just keeps going. There's no pattern to it, and you can never write it as a fraction. Now, if you take all the numbers that you can write as fractions and all the numbers you can't, we call that the real number system. Essentially, those are the numbers you learn about in Algebra 1, real numbers. There is something beyond real numbers, okay? Complex or imaginary. We're not going to talk about those right now. Okay? Now, because some of these number sets are used a lot, they have symbols to abbreviate them. So if you see a symbol that looks like that, it's kind of like a Z with that double line in it. That symbol is used for integers. Why a Z? I'm not sure. I don't know. They use a Q to represent rational numbers. Can anybody think of a word that begins with Q that has to do with fractions? Yep.
Quarter.
What is it?
Quarter.
Quarter? Okay, so like a quarter of something, that would like 1/4, that would be, yeah.
Quotient.
Or quotient, when you divide two things, you get a quotient. So I'm guessing maybe that's where the Q comes from. I don't know. And then a capital R with that extra line, that's the symbol that means real numbers. Now, sometimes you might see these symbols modified a little bit, like this. If I put that plus sign next to the Z, what do you think I want you to, or what do you think I'm referring to now? A Z with a plus sign. Yep.
A positive integer.
Right, specifically a positive integer. Or, in that case, I want you to find a negative integer. Okay. The other number sets, like counting numbers, whole numbers, and irrationals, they don't have symbols that I know of. Okay. Any questions on this? All right. So there are four binary operations in math. Binary means it's an operation that takes two things, and that's add, subtract, multiply, and divide. Okay? You can't add one number. If you want to do addition, you have to take a first number, a second number, and then you can add them. But you need two. If you're like, well, isn't everything in math take two numbers? No, the square root doesn't. If I asked you to take the square root of something, you just need one number. You don't need two numbers to do a square root. But any of those, you need two. And what we're going to look at next are some properties in math. You might have seen them before, like commutative, distributive, associative. It's going to quickly go through some of those. In the properties that I list, I'm going to use the variables a, b, and c. And a, b, and c can represent any real number. Now remember what real means. Positive, negative, zero, fraction, decimal. Basically anything. Right? So the first property is the idea of closure. What closure means is that, let me give you an example. 3 is an integer. 4 is an integer. The answer is 7, and that's an integer. This is an example of closure. You started with an integer. You started with another integer. You did something to them, and the answer was an integer. So the idea is, whatever type of number you started with is the type of number you finish with after you do something to them. With addition, you would always start with an integer and end with an integer. With subtraction, I could change it to subtraction. It doesn't matter what two integers you subtract. Subtracting two integers always gives you an integer. So we say that that means it is closed. You stay within the same set you started with. Now division does not work for this property with integers. Take an integer, divide by an integer, and you don't get an integer. So you started with integers, but you did something to them, and you didn't end up with an integer. That means the division operation is not closed when you use integers. Any question on that idea? So it's just the idea that you start with a type of number, you do something to it, you always end up with that type of number. How about this one, commutative? This has to do with the order. Okay, when you do addition, it doesn't matter the order that you add two things in. Right? That's called the commutative property. How about associative? Does anyone remember what that one is? Associative doesn't have to do with the order you do something in. It has to do with something else. Think about the word associate. It's kind of like part of associative. Associate. When you associate, do you do it alone? Or do you associate in groups? Yeah.
So associative is like, it doesn't, if there's like a group, like say it's like 3 plus 4 in parentheses and then 5 plus 3 and another set of parentheses, it doesn't matter what order that the parentheses are in.
Right, so it has to do with parentheses and how you group them. So generally you'd have to have 3 things you're adding. So the order here is exactly the same on each side. ABC, ABC. What's different is, what are you doing first? How are you grouping what you're adding? That's associative. And a lot of these same properties work for multiplication. I'm not going to write them all out for multiplication, but the commutative property does work for multiplication. 2 times 5, 5 times 2, same thing. Okay, identity property. The identity property is something you can do to a number, and it doesn't change it So what would be the identity property for addition? What could you do to a number that doesn't change it? Yes, Lauren? Sorry, go ahead. Yeah. Yeah, you could add 0. So if you add 0, it stays the same. Now, would that be the same for multiplication? Multiply by 0? No, what would it be for multiplication? Yeah. You multiply by 1. That'd be the identity property for multiplication. But that's for addition. The inverse property for addition is something you can do to a number to get 0. Basically, the idea of the inverse property is to cancel something out. So you might see that when you solve an equation. 3 plus x equals 10. To solve that equation, you do the inverse of 3, because you want to cancel it out and get a 0. What's the inverse of positive 3? Negative 3. And that becomes a 0. That's that property right there. Inverse property. Okay. And the last one is distributive. So distributive property is when you have something on the outside of parentheses and you multiply it to what's inside. And usually we show something like that. As I said, all these properties are also in your book on page 2 for multiplication. Any questions on those properties? All right, so what makes something in math an equation? Okay, an equation is when you have an equal sign between two expressions. Okay. That's called an algebraic expression, 3x. There's an equal sign. 5 is a numeric expression. So I have an algebraic expression on the left, a numeric expression on the right, and an equal sign between them. 3x equals 5, that's like 2x equals 12. Those are the same type of equation. That's called a conditional equation. It's called conditional because it could be true if you pick the right value for x. How about 5 equals 2? Sam, what do you think about that? 5 equals 2.
I'm not gonna lie, I'm falling asleep. I've been trying to listen the entire time. I've been like half in.
So if you look at that equation, what do you notice like about it? 5 equals 2.
It's not that nice looking, I know that.
Why? What's wrong with it?
It doesn't really give any sort of hint as to how to really justify the equation at all.
So if you ended up with something like that, like let's say this was algebra 1, 3x plus 5 equals 3x plus 2. In algebra 1, someone might say, okay, subtract 3x from both sides. And when you do that, now you end up with 5 equals 2. So what would that mean, 5 equals 2? Yeah? They are not equivalent. That's false. That's an equation that can never be solved. It's 5 does not equal 2. There is no way to solve that kind of equation. It's still an equation. It's just an equation that's not solved. Now, how about this one? 3 plus 4 equals 2 plus 5. What do you notice about that? Yeah?
The numbers are different, but they're still equal.
Yeah. So that would be something like this. If I said 3x plus 5 equals 3x plus 5, and you subtract 3x from both sides, you're going to end up with 5 equals 5. What that means is that it's an equation that is always true. You can't pick a value for this equation that would make it not work. It's impossible. If every value would work. So this is an equation that is always true, an equation that's never true, and an equation that is sometimes true if you let x equal 6. But the point is, they're all equations. So the last three properties we're going to look at are going to be properties specific to equations. Let me do it this way. That's the first property. Something equals itself. Does anybody remember what property that is? It begins with an R. If you have something equal to itself. Yeah? Reflexive. Yeah. So that's called the reflexive property. A lot of times you see that property if you are doing something in geometry. So that's reflexive. The next one is called symmetric. And what the symmetric property lets you do is if you end up with something like this, you could switch what's on each side and say that. It means the same thing. So you might say, well, yeah, isn't that just a commutative property? You can just switch the order. No, commutative property is when you switch two things on the same side. Symmetric is when you switch the entire sides. So it's a little different. And how about this last one? It says if A equals B, and then B equals C, then A must equal C. Yeah?
The transitive?
That's a transitive property. So transitive property is when you have a chain of things equal to each other. It can be, that's just 3 things, but you could have 4 things, 5 things, but that's transitive. All right, so what I want to do now is just look at an example of a kind of problem you could see on a test using these properties. All right, so what they've done in this problem is they've given you an equation, and they basically want you to solve it. They're telling you the steps, but they just want you to write out the step, okay, what you would do. So they're telling you that to solve this equation, the first step is the distributive property. How about right? What side do I have a distributive property on?
On the left side.
Yep, on the left. Can you tell me what I'm going to distribute on the left? The 2. So in this step, all they want me to do is write out how you would do that. You don't even have to simplify it yet. That's the next step. Just write it out. So that means 2 times x plus 2 times 3. That's what the distributive property needs to be. That equals 6 plus 2x. How about, Alex, what can I simplify now? Because they said that's the next step. You see anything that can be simplified on the left?
2 and 3.
Yeah, what do you get? 6. So 2x plus 6 equals 6 plus 2x. Now technically those are not exactly the same because they don't have the same order, but you can switch the order of the 2x and the plus 6. That's the commutative property. So that's all you're doing in the last step. Switch the order of those 2. And this kind of problem, we could do it either way. I could have also given you all the work and said, okay, what step is this called when you distribute the 2 to each number? And then you would have written down distributive property. So you could do it that way as well. Okay, any questions on that? All right, So a lot of the things you see today, it's going to be stuff you've seen before. So we'll go through it kind of quick. But this is a number line. We always call the number right in the middle on the number line the origin. Positive numbers to the right, negative numbers to the left. Now, once you start thinking about a number line, then you can put two numbers on it, and we can start to give an order to numbers. There's four symbols that we use in math to describe one number compared to another one. Does anyone know what I'm thinking of? Yep.
Is it like greater than and less than?
Yep, it's this. So there's four of those. If you remember what those are all called. Greater than, less than, greater than or equal to, less than or equal to. There's a name for those four symbols. Lauren?
Inequalities.
They're all called inequalities. Yep. So when you create a number line, now you're creating the idea of order. That there is a such thing as one number being bigger than another. In general, numbers to the right are bigger numbers. If a number is to the left of another number, it is smaller. So let's go through the symbols, just make sure we remember the names. So the top one is less than. How about the next one? When you put the line under it, Ashley?
Less than or equal to.
Less than or equal to. Yep. The third one? Symbol is that. That. Greater than. And of course, the last one, when you put the line under it, greater than or equal to. So those are our four symbols. Those are called inequalities. So on a test, if I ever ask you to compare two numbers, and I say use an inequality symbol, like to compare those two numbers, that means to fill in one of those symbols in the blank. So, how do we graph on a number line? Well, you're going to be doing graphs that look something like this. So you might have a closed circle, or you might have something with an open circle. How many people remember doing those kind of graphs? Okay. So whether you want to graph something and use an open or a closed circle, it depends on the inequality symbol. If the original symbol is a greater than or a less than, we use an open circle. If it's a greater than or equal to or a less than or equal to, we use a closed circle. So there's really three things you have to decide when you want to graph. What type of circle, what number does it go on, and then which way do you shade? So the first one is x is greater than or equal to 2. Okay, what kind of circle am I going to use for this problem? Open circle means it's not filled in, or a closed circle, which means you shaded it. Yeah, Chris?
A closed circle?
Closed circle. Can you tell me on what number?
Yeah.
On number 2, so we need a number line. So closed circle on 2, I agree. And can you tell me which way I shade if I want to shade all the numbers that are greater than 2?
If x is greater than 2, you're going to want to circle all numbers greater than 2.
Which is which way?
Right.
To the right. Yep, good. So we're shading everything greater than or equal to 2. Now, you might see it written like this sometimes. I don't like to write it this way. I always like to write it variable on the left, number on the right. Because if you write it with the variable on the left and the number on the right, this symbol tells you which way to shade. Even though this is equivalent, if you put the variable on the right, this tells you the wrong way to shade. So I write my inequalities letter, symbol, number. That's how I always do it. Okay, so we got that. How about, again, this is the same idea. I would prefer to see it this way. Letter, symbol, number. Even though this is technically the same thing. And how about, Maddie, what kind of circle would you use this time? Open. And what number would you put it on?
3.
Put it on 3. All right, so let's just go with this. So open circle on 3. And Eileen, which way would you shade?
To the left.
To the left. We want to shade everything that is smaller than 3. That's to the left. Okay. Any questions on that type of graph? Okay. So open circle, closed circle. That's one way to graph something on a number line. Another way we can do it, and you're going to see this pop up in our book, is instead of a closed circle, you might see a bracket. It means the same thing. You can use a bracket in place of a closed circle. I'm going to do the same problem we just did, but now I'm going to do it as a bracket. So, because this is a greater than or equal to, we would normally like to use the closed circle. Another symbol you can use that means the same thing as a closed circle is a bracket. So in this case, you put a bracket on 2. The one extra thing you have to think about is the bracket has to face the direction you're going to shade. So you got to kind of think about that beforehand. I already know we're shading to the right because we did this problem. And that's how you do it. I don't care whether you use a closed circle or you use a bracket. What I care about is, like, if I gave you a multiple choice question on a test and I gave you this as a picture, I might ask you, how would you write that as an inequality? And you'd have to know that it means x is greater than or equal to 2. So you can use a bracket in place of a closed circle. Anyone ever guess what number you can use instead of an open circle? Not number, what symbol? Have any guess? Another symbol you think we might use that looks kind of like that, but it's a little different, yeah? A parenthesis, yeah. So instead of using an open circle, in our book, you will see a parenthesis. Again, when you have to graph something on your own, I don't care which symbol you use. You just have to know there is another way to do it. So in this case, less than means to use an open circle. Parenthesis can take the place of an open circle. Same with the bracket. You need to face the parenthesis which way you want to shade. We want to shade less than 3. So parenthesis, shade everything to the left. Just like that. Okay, so probably a little bit new, but does anyone have any questions on that? Okay. Now, the last type of graphic we can do on a number line involves something like this. So this is what we call an and statement, right? It's another word for it is a conjunction. It means usually shade between 2 numbers. It doesn't mean to just mark one number and shade forever. Usually you're going to mark 2 numbers and shade in between. This is the short way to write a conjunction. This is the long way. You should be comfortable from Algebra 1 with changing one into the other. And if you're looking at it and you're like, well, how do these 2 things come out of this one? Well, this part right here is that part right there. X, and then it's pointing at the 2. X, and it's pointing at the 2. I know the order is switched. That green part comes from right there. This is that x is less than or equal to 9. So the notation in the black box up here just saves you a little bit of writing. But it means the same thing as what's below. Any question on that? All right, so let's graph that. And we can choose whether we want to use the circles and parentheses or the parentheses and the brackets. But don't mix them. Either use one or use the other. All right, so we need a number line that goes from 2 to 9. So let's go. That's good enough. What kind of symbol could I use on the 2? Yes, Caleb?
Close circle?
Yep, so because he said circle, we're doing circles now. We're not thinking brackets or parentheses. So closed circle, but you could have done a bracket. And what kind of symbol do I need on the 9? Yes?
Also a closed circle.
Also a closed circle. And if I want to shade everything that's greater than 2 and smaller than 9, where would I shade? Max?
Just in between two circles.
Yeah, just in between. So that's how a conjunction looks. Any question on that? All right, so something in Algebra 1 I probably would have spent the whole day on just graphing like that, but again, we're just going through it quick just to try to remember some of that. Absolute value. Does anyone remember what absolute value is? Yeah?
So absolute value is pretty much you put an equation between these like 2 lines, and then it's just the absolute value of that. So like let's say the answer was -5, it would just be 5.
It would just be 5. So yeah, absolute value always gives you what kind of number for the answer?
Positive.
Positive, or technically it would give you 0, which is not positive or negative. But it could be 0 or higher. You'll never get a negative number when you do absolute value. Yeah?
I believe it was called a real number.
When you do absolute value, you will always get a positive real number or 0. You'll never get a negative real number. Yeah. So one way people think of it is the distance from 0 on a number line. I'm not going to spend too long on this. I think most people are pretty good, pretty comfortable with it. But what would be the absolute value of 6? 6. And the absolute value of -3? 3. Okay, so absolute value is essentially just make the number positive. If it was already positive, we don't have to do anything to it. How about the absolute value of 0? 0. Stays the same. 0 is the only number you can take the absolute value of, and it stays the same. Okay, any questions on it? All right, absolute value. And absolute value allows us to find distance. Let's say you had a point here called A and a point here called B. You could think of A and B as 2 grades. Like maybe you took your first test and you took your second test. How do you find the distance between 2 numbers? What operation would you use in math? Yeah? You use subtraction. And if you take the absolute value, then it doesn't matter what order you do with it. Like, let's say these were test grades. You got an 80, and you did a retake on it, and you got a 90. And I said to you, what is the difference between your first time you took it and when you did the retake? Well, if you do 80 minus 90 and take the absolute value, you get 10. If you do 90 minus 80 and take the absolute value, you get 10. So, subtracting 2 values gives you how far apart they are. All right, let's try this one. Find the distance between -2 and -9. So think of this as A. Think of that as B, and fill it into the formula. negative 2 minus 9. So absolute value is like a grouping symbol. You do what's inside it first. What's going to happen here? Minus 9. Yes, Jess? You're going to add, right? It's going to become negative 2 plus 9. Negative 2 plus 9 is 7. And what's the absolute value of 7? 7. So in other words, if you put those two numbers on a number line, negative 2 and negative 9, they are 7 units apart. Okay. Questions on that? All right. Okay, two-dimensional. Can somebody tell me anything they know about two-dimensional graphing? Yeah.
There's a y-axis and an x-axis.
Yes, there is. There's an x and a y-axis. Which one is the horizontal?
Horizontal is x.
Yep. And the vertical is the y. When you draw those two axes, like if you did it on a piece of paper, they would separate your paper into 4 sections. Does anyone remember what you call those sections? Lauren? Quadrants. How about where the x and the y-axes cross? What's the name of that spot?
Origin.
Origin. Okay, we didn't go over the numbers of the quadrants, but quadrant 1 is the upper right, 2 is the upper left, 3 is lower left, 4 is lower right. I've also marked what kind of well, I'm going to ask you what this thing is called in a second, or maybe I'll ask you right now. What is this thing called? Yep, it's a coordinate. So I've marked what type of coordinates you can find in each quadrant. In quadrant 1, the x and the y value are both positive. In quadrant 2, the x is negative, the y is positive, and so on. Positive values go to the right and up. Negative values left and down. So this thing that I just asked what was called, and Matt told us, that is called a coordinate. The specific type of coordinate, this is an ordered pair. Means it has 2 things. When you get into 3D, you have what's called an ordered triple. That's x, y, z. And a coordinate is how you specify a location in 2 dimensions. You give an x value and a y. Any questions on anything in that diagram?
What'd you say?
Any questions on that? Okay, so this is probably going to be new. So on the graphing calculator, sometimes we draw something and it's not on the screen. We have to fix it so we can see it. Let me show you an example. You can just watch what I'm doing right now. Or I guess if you want to practice typing it in, you can. So the first thing you want to do is turn your calculator on. If you ever want to get back to the main screen where you can do just arithmetic and stuff like that, you can press second and then the mode button, and that's quit. Second quit brings you back to the main screen. If there's stuff on there you don't want, you can press clear. That's all the way on the right-hand side, right below right above the exponent symbol. You don't have to clear it, but if you want to clear it, that's how you clear it. All right, let's type something in. I want you to press the y equals button that's in the upper left. On my calculator, it's gray. On yours, it's yellow. If you have anything typed in, what I would do is just go ahead and press clear. So your screen looks like this. Is everyone at a screen that looks something like that? Okay. So what we want to do is type in x squared plus 10. So to type in an x, it's the button right next to alpha. It has x comma t comma theta. So that's how you type in an x. Now there's two ways to do squared. I want to show you one way that'll work for any exponent, but there is a button specifically for squaring things. But this is how you could do it no matter what the exponent was. Press the up arrow, or not the, it's the caret symbol right above the division sign. Press a 2. Now the problem is, if you keep typing right now, you're going to be staying in the exponent. We don't want to type anymore in the exponent. So once you have a 2 in the exponent, press the right arrow. That will bring your cursor back down to the regular line. And now we can do plus 10. Oops. I have an extra symbol in there. There we go. Plus 10. So I don't know why I have an extra symbol. Oh, it's gone. I don't know what that was. So you should have a screen that looks just like that. X squared plus 10. Does everybody have that? All right. Now, I want you to press the window button. The window is where we control how much of the screen do you want to see. The standard window is -10 to 10 on the X and -10 to 10 on the Y. I want to leave it just like that. If yours is not set for a standard window, well, does anyone have different numbers in here? That's fine. We can set all those numbers automatically without typing them in. The way you can set all of them to -10 to 10 is press zoom, and then the sixth option down is standard. So the standard window is -10 to 10. So do zoom, and then press 6. When the yellow circle is spinning in the upper right, that means it's doing something. When it's done spinning, it's done. How many people got a picture that looks like this? All right. So we definitely typed something in. The question is, where is it? Well, the plus 10 moved it off the screen. So this is how you change your window to fix it. We're going to specifically try this window. Instead of -10 to 10, we're going to go -20 to 20 on every. When you see something written this way, this is what the numbers mean. On the calculator, that is the x min. That is the x max. So the first two numbers are x values. The second two numbers are y values. Y min, y max. Now, technically, in this problem, there is only one number you need to really adjust to be able to see the graph. It's that. But we're going to practice adjusting all four of them. So on your calculator, you want to press window and type those four numbers in the four spots that they go. So x min, -20, and then just hit the down arrow. X max is 20. Y min, -20. And I should mention it while I'm here. On this calculator, there is a difference between the negative sign and the minus sign. They're not the same. The negative symbol is below the 3. If you want to do a subtraction problem, that's the button above the plus sign all the way on the right. You can't use one in place of the other. Actually, I'll do it and I'll show you what happens. Let's say I accidentally put a subtraction symbol there. This is not going to work. It says error. Syntax means you put in a symbol that you shouldn't have. Okay? So if I hit go to, it brings me back to that, and that's not the right symbol. That's a subtraction sign. I want a negative sign. Now it's okay. Now, once you put in those values, we're going to hit graph again. But first, did anybody not get those values put in? Okay, so hit graph. And if you've done everything right, you should see a graph that looks just like that. Okay. How many people saw a graph like that? Okay. Anyone have trouble? Yes. What happened? Did it give you an error?
No.
No?
Well, I did that first, and then I realized like what I was doing.
Okay.
That's what I thought.
So go to your window.
Okay.
Negative 20 to 20, negative 20 to 20, not 2.
Um,
So that should be okay now. When you hit graph now, you should see it.
Yeah.
So, what we were looking at before basically was this. That was the window. Essentially, we zoomed out so we could see more graph. That's probably the toughest thing about using the graphing calculator, is finding a graph if it's off the screen. There's tricks we can use when we start to learn a little bit more, but that's one way you can do it. You can change your window. Now, you might think, well, why don't I just set my window like negative 10,000 to 10,000? Why don't I just make it huge? Well, the problem is, if you make it too huge, the graph starts to get really tiny, and then you can't see. So you don't want to make the window so big that you can't even tell what shape you have anymore. It'd be like looking at your house from outer space. It's like you can't even see it, and it's too small, right? And I think that was it for that. So any questions on that? So in the homework, you'll see some problems that say, practice setting your graphing calculator, or they might use the word graphing utility. They might even say grapher, but they'll say something like that. Practice using your graphing calculator and set a window, and then they'll give you numbers. That's just practicing on your calculator. There's nothing to write down on paper for that kind of problem. Okay, so some of the homework problems I give you are purely just practice on the calculator. You don't have to write anything down. Okay, and last thing. So, distance formula. So the distance formula is basically a way, if you had 2 points like this, to figure out how far apart they are. And that is the distance formula. And if you look at it and you think, well, it kind of looks like Pythagorean theorem a little bit, you square something, and you add them up. That's because it is the Pythagorean theorem. It's the Pythagorean theorem written using coordinates instead of sides of the triangle. But it's exactly the same formula. So the real important thing I want to get out of this problem is when you're done, your very last step in the distance formula is a square root. There are some numbers that when you take the square root of them, you can simplify them. Like this. Square root of 20 is a number that can be simplified. So when we get to this last step, we'll go through how to simplify that if you don't remember. There's lots of ways to do it. I don't care how you do it. I just want you to do it. Right? Simplify square roots if you can. All right, so let's try finding the distance between those 2 points. 1,4 and 5,6. Because the distance formula has a lot in it, it's got parentheses, it's got squaring, it's got square roots, I like to write down the whole formula first, so then I don't forget it. So distance is the square root. I'm going to subtract 2 things and square them, plus subtract 2 more things and square them. Now I won't forget any of the symbols. Now we fill it in. Matt, can you tell me what I could put right here for my first number?
1.
Yeah, we could put 1. Okay, so we've used We've used that. And how about my second number? What? Yeah, go ahead, Matt.
5.
Yep, put in 5. Good. Could have done 5 minus 1, it wouldn't have really mattered, but 1 minus 5 is good. Wyatt, how about these two numbers?
4 and 6.
4 and 6. Perfect. All right, let's simplify it. 1 minus 5, Kelly, what does that give you? -4. And what's -4 squared? 16. Plus, Casey, what's 4 minus 6?
2. Wait,
-2, and then when you square it, 4. So we get the square root of 20. It's exactly the square root I just mentioned up above. Does anyone remember how to simplify the square root of 20? Next.
Would you break it into the square root of 4 and square root of 5?
Yes. The goal is to break it up as a multiplication problem. And the two numbers that you multiply together have to give you that. So he could have done 2 times 10, but 4 times 5 is better. Because when you break it up, you want one of the numbers here to be something you can do the square root of. Okay, 4 is a perfect square, which means you can take the square root of it and get a nice answer. What's the square root of 4? 2. So the answer here, 2 square root of 5. So reducing square roots is something we'll do, not really something we learn here. It's more of an algebra 1, algebra 2 kind of thing. But definitely, if you get stuck on it, I will help you. Any question on the distance problem? All right, last problem. So the last problem is what's called the midpoint formula. The midpoint formula gives you a way to find what's halfway between 2 points. And that is the midpoint formula. Now, if you look at what you're really doing in that formula, look at the x's first and then look at the y's. You're adding two things together, and then you're dividing by 2. What's that called? If you add two things together and then divide by 2. Yeah,
That's averaging.
yeah, it's averaging. That's all that the midpoint formula is. It's 2 averages. Add the x's up and divide by 2. Add the y's up and divide by 2. What's the average x value? What's the average y value? That's all that formula is. Okay, does everyone have the formula? Okay. So let's see if we can find the midpoint between those two coordinates. -5, 2, and 3, 7. Again, I usually just like to write the formula down that I'm going to use, and now I'll fill it in. So, Lucas, what could I fill in for my first number?
-5.
Yep. So -5. That's x1. And Elijah, how about right there?
That would be 30.
So we want to make sure we use our first x value and our second x value. So 3 is the second x value. So that's perfect. So -5 and 3. Now we want to use the 2 y values. Okay, first y value, Sam? 2. And Alexis, my second y value? 7. And now, just write the coordinate. Quinn, what's going to be my x value here?
Your x is negative 1.
X is going to be negative 2 divided by 2, which is negative 1. And my y value, how about, Jalen, what's my y value?
I got 4.5.
Yep, so it's 9 over 2, so you can leave it as 9 over 2. If you want to change it to a decimal, that's fine as well. Either way. Alright, so that's section 1.1. There's a lot of stuff in that section, but I hope most of it was reviewed. Maybe except the zooming on the calculator and the bracket. Questions on it? So that's the homework for tonight. So page 11, and then those questions. This will be in the this will be on YouTube in the playlist for you guys in about 5 minutes. So if you forget it or you lose it, you can copy it from the video. But you do not have to do every problem on page 11. There's probably 70 questions. All right, so just those questions. Any questions on what the homework is? Any questions on where to find page 11 on